Yeah, that's cool. I don't know how bad the sound is from my headphones. I know I can't use them for music. See, I do need to. Hello, chat, by the way. I might actually. Let me plug this thing in. I'm just gonna use. Well, I won't be able to hear it, but. Um, around, around. Go pull this guy out of here because I need to charge my headphones. We're gonna go here. And then we're gonna percent. Charge those guys up. Like there. Right. Meme review. Good, that works. Alright. Hello chat. We're not doing this guy. There might be some interesting things here. I don't know yet. Close this guy up. This guy is not the one we want. It is this guy, I think. Might really name him. Is this the one? That is the one. Yeah, I think if I scroll up far enough. I do need to scroll for a while because I because I helped it. Yeah, actually, that thing. Oh no, this is just for that thing. So it would actually be this thing, I think. Yeah, this is the one. I got confused for a second, Jeff. Give me 1 second. I'm just gonna go blow my nose. It probably was. Oh, cool. Alright, chat, I'm back. I need to. Give me 1 second. I'm just gonna clean my glasses. I'm actually getting like a little bit of headache from it. Okay, chat, I'm back. I'm back. Yeah, so we were here. I'm asking about some things from the thing, but up here we were learning. A little further up. So, how these things here for the. Oh, I'm sorry, for this guy. So let me bring that up. I'm probably gonna rewrite that whole question. Um, it's a pretty good idea. Now if we go here, there's some things here. So look, March 13th. That's in a week. Cool. Now we will solve problems from the March exam on the board. Yeah, and by that time I will have looked into them a little more. That's good. This looks like a pretty similar problem. So yeah. I'm a little curious. I'm gonna click on this button. my equation. Wait, when is that? Wait, I'm gonna go grab my. Wait, I can. No, I can't check it on my iPad. I don't think it has. Wait, I can check. I'm just gonna very quickly check chat if when that exercise session is scheduled. My understanding. Right, there's an exercise session tomorrow, which I assume will be this one, which I'll definitely be going to. So that's nice. Oh wait, there were one on yesterday apparently. Right, well, maybe I should have gone to that one then. Oh well, I'll go to the second one here. That seems interesting. Or maybe that's the one that's been moved. Probably. Ah, fuck. Then I should have gone to this one. Oh well. Oh well. Yeah. So let's get back into this game here. I'll try and understand as many things as possible. I'll spend a little while longer on the exercises from this thing, because the exercises in this course are heavily linked to the actual exam and the solutions and such. So it'll be very representative. It's good. Let's see here, like here, right? So there's this thing here we should do. I want to redo this one. I did it before, but I didn't entirely like get what the fuck was going on. I should put my iPad in the charger if I'm gonna go to the summer leisure. Wait, I actually need to have a shower at some point. Do I? I can maybe survive, but it's not a bad idea. I need to change out my clothes. Missing the summary lecture would be fairly annoying. So the exam is coming up fairly quickly, so I do need to lock in like now, essentially, the coming days. I do. Oh no! What the fuck happened? Why did my computer decide to? Did the stream drop? No, the stream looks fine. Okay, interesting. Yeah, so I might not spend too long on this then. Oh God, I'm actually feeling very stressed about it. Problem here. Okay, let me do this guy here then. This will work. Yeah, there we go. I am still fairly sick. I do hope that will get better as time goes on. So to minimize parity of ut squared, right? Can I click the thing? There we go. Yeah. Equals 0 u squared, where with the dynamics of x t plus 1 is 2 times xt plus ut shows and controls stabilized system. So we have our initial policy mu 0 of x minus 2x So we are computing the cost function. Yay, mu 0 of x. So we're solving the Bellman equation. So EA mu 0 of x equals mu 0 x squared plus j mu 0. So that's the initial step, or whatever we should call it, of 2x, and then the future cost to go and future costs. Is that the right word for it? I think that's the right word for it. So I want to solve this thing here. Is it doing it here in the background? He's like thinking about it, which is cool. I'll let him cook for a moment there. Hopefully he will get somewhere. But yeah, so we can insert the yeah, sorry, exactly. So we apply it to the thing. Yeah, so we write apply policy. I wrote policy wrong. Policy. So write it like this: mu 0. And you guys can see what I'm doing, but I don't care. Minus 2x to apply this gives us ut equals minus 2xt and then when we insert this guy into the dynamic, we have 2xt minus 2xt, which is equal to 0. So the system instantly goes to 0 with one step. With cost so we know that the cost j of mu 0 now of x is equal to minus 2xt squared, which is 4xt squared, Okay, so a single step costs ut squared from here. So we're taking one step. So 1 here, or t is equal to 1. Just that thing, and then plus those other things. So plus, I'm gonna write the plus 0. As xt plus k equals 0 for all k greater than or equal to 1. The final cost is y mu 0 x is equal to 4 times x squared, which is cool. Now I'm gonna do my last look again. Like, these things make sense. This is what we did on the thing. I am learning a little bit. I'm understanding a little bit what is going on, which is nice. And then the next question there, compute everything here. B. Compute the updated policy. So we have mu1 is, it's mu1 of x. So let's actually be good about that. Of x is the argmin u of, well, there's squiggly brackets, so it's not about it. U squared plus j mu 0, so you're using the previous. Oh, that's just a, no, that's just the same. Well, this should probably say j mu 1 there, right? Oh, okay, the next part there is computing. So wait, should it say j mu 1 there? U of x. Here's the thing here, right? So we'll minimize this thing. According to this thing here. So j mu 0 we calculated in the last step. We know that one is 4x squared. The plus u there, so you put the thing there, right? So if I'm gonna look at GPT's answer soon. Let me just like write this out. So you have I write it like minimum of u given u squared plus 4 times 2x. So I guess we can put a t there. I mean, those things will be, that's a 4, that's a t, and that's a u. That fucking 4 looks ugly as it balls, man. 4 u. And this thing here is squared. So I mean, we don't actually, if we're gonna find the minimum, we can derive it to find the local minimum. I'm gonna set it 0. We can also like expand it. So let me do that. You don't need to, but I want to because that's how my brain prefers to solve these problems, to make sure that everything works out correctly. So then you have 4. God, my u's and 4's look way too similar. So now we have this thing here squared. So we have 4x squared plus this one times 2, which is 4x u, and we have plus u squared. Yeah, and then the 4 times there, so this can be min of u of ut squared plus 16x squared plus 16ux plus 4u squared. And this is min of u of 5u squared plus 16ux plus 16x squared. Derive and find minimum. Right, so now we derive this, then that's 10u plus 16x equal to 0. So u should be equal to minus 1.6x. Would be a local minimum. Put that into the thing. Mu1 insert into mu1. Can we utilize the dynamics of the system as well? No, I don't think we need to do it. I mean, we'll check that the thing later. Sometimes you did that in the thing before. So mu1 here would then be I mean, I'm just gonna write it like this. 10 divided by 10 squared x squared. Well, we can actually put it into this part here, right? Yeah, we can do that, and that's, yeah, I mean, it's the same thing. So then it should be for 2, so 8. Well, I'm gonna write it like this. 5 times 16 divided by 10 squared x squared plus 16 negative 16 divided by 10 x squared 16x squared. And then this is still equal to, so it's, so we'll write it like this: 5 divided by 100, 16 squared x squared minus 16 squared divided by 10 squared plus 16x squared. And then, I mean, you can do a bunch of math here if you want. Okay, I guess we have to. Yeah. I want a different pen. So this time times 10, this guy times 10, this guy times 10 divided by 10 Or this time is 100, I guess. No, we should have 16 squared times 5 minus 16 squared times 10 1600 divided by 100x squared, and then this, I mean, yeah, that number I can continue doing the fucking 16 squared, right? Because it's 8 times 4, so it's what? It should be 64, right? Yeah, it's no, it's not 64, it's 128. 16 times 16 is 256, yeah, exactly. So it's 16 squared times 5 minus 16 squared times 10 minus plus, that's a plus sign. 16 times 10, or 16 times 100, 120, so it's 3.2. At the end of it all, it is 3.2 x squared. Apparently, if I've done, I've done something at the very least. Oh no, I wasn't supposed to close that. I don't know what page it was on. Something like 40. It's a little higher. It's nothing, not crazy how much higher now. Okay, it was actually quite a bit higher. Close to 31. Yeah. Okay, regardless, here. So we have this function here. Did I fuck something up? Wait, somewhere it looked like I did. I got wait, where did I fuck this up? Because I've done something very, very similar. You insert this thing here, which becomes this thing here. Wait, let's have a look. There's a 5 where I've maybe written a 10 somewhere. No, 5u squared plus 16xu. Yeah, and I need to derive this thing. So I have 10u. Right, no, okay, yeah, that part there is correct. So u is equal to that thing there. So u is equal to, wait, I must have done something wrong with my, or wait, then you put that into, wait, what? Aren't you then supposed to put that thing back into the thing? So u is equal to 1.6, which is the optimal point. So I put, yeah, because then I put that thing, so then I inserted the u into or the minimum of the thing. I inserted that. So is that wrong? What I did here then? For step 2, I took the u equals minus 1.6 x and inserted it into the formula. Inserted into the expression, of can I copy this mu so I can, so I want to write it as m because it's wrong. Mu1 in your answer you seem to just put the equals to u. Or am I missing something? I can check the answer here. Let me duplicate this thing. So I can check. And now it'd be closer to page 41. It's actually further down than 41 because it's towards the end. It takes so fucking long to load. It's further down this here. Argument of that thing is gives us that thing. Okay. So yeah, I have just misunderstood it then. So our u. So the u that gives us that thing. Because we've inserted the okay, yeah. And that is the so it's the arg part. I'm missing them. Let's see if it actually like explains that to me. Because I mean that it makes the u is here. Let me like wait. This is wrong. Mu1 of x argmin. Oh, I'm just gonna this. (1.6) x. Once you solve for the minimizer, that is the new policy. For each x, find the u that minimizes the expression. You immediately say mu1 is there is no extra steps beyond that. Improvement you do a minimization over the scalar u, the controller input. You get an expression. I mean, yeah, look, it does a good job at actually explaining why this is wrong. Like again, this is useful. This is what I want to use AI for. This is why it's good, because then you can like ask, like, oh, wait, why isn't this thing correct? And then it like tries to explain it to you. So this is like a good example of like when AI, how you use AI to actually like be a useful tool for you. Sometimes you'll then evaluate the cost of the new policy by substituting into the dynamics or cost function, but it's a later step, policy evaluation. The improvement step itself ends as soon as you identify the new function. Right. Yeah. And that's the next part there. So that might make sense. I think I might have a shower pretty soon. And like eat food, and then I'll spend some more time, and then I'll leave for the thing. It's all fine. I could actually eat another lunch, and I could like leave, and I could like sit and like work in school. That could work. That could totally work. You wanna do that? Maybe. What the fuck did I work? I had some sandwiches not too long ago. It's nothing crazy. Yeah. Well, half an hour here. Just looking at this thing. Might like just do another. Do C here, and then D, and then be done there. Shouldn't take too long. So if we then compute the cost function, so that is solve the Bellman equation. So for C, solve Bellman equation. So again, we have J mu1 of x, right? It's of x here because it was of x here. Just making sure they're not stupid. Yeah. And then here it's mu1 of x. What's this thing squared? It's squared because of this thing here, right? Think of maybe here plus mu1 of u squared plus not j, that's not a j in there, it's the cost of the thing. So it is mu1 of x squared here and here squared mu1 of u, not of u squared, but of 2x here, because that's the step of the thing. No, because of this thing here, right? That's why here, because you're taking the step. That's the thing. That makes sense. I just needed to think about it for a bit, make sure that I wasn't fucking it up. Or I mean, I was about to fuck it up. And like, yeah, because there's so many moving parts in this, and I don't. Jx plus mu1 of x. Right, so you look one step into the future or something. Right, so that's the thing there. I don't know. I don't know. I don't know. Oh, right. So then we insert. Yeah, and then yeah, because here, there, we write. So we give it a new. So applying mu1. That's a not very good looking mu. Let me write a better mu. Applying mu1, which is equal to, or which says like u should be, what did it say? Minus 1.6, minus 1.6 x to the dynamics, which was xt plus 1 is equal to 2xt minus 1.6 xt, because originally it was plus in the thing, in here 2 times xt plus ut, which is minus xt, which is 0.4 xt. I buy that. Cost each step is ut, cost of each step, right? So for each step we take, this thing here, of x squared to the mu. Just a different way of writing it, I think. Yeah. Wait, so do we need to write, we need to actually calculate this then? 3.74, which is very close to what they get. Some sort of thing. Okay. Right, so I should be able to do it in the same way that I did up here, right? Just solve the fucking equation, right? So if you just write the equation down, again, mu1 x is equal to mu. Don't need this thing here, right? So just have the value. Because that thing squared, which is it's 1.6 squared, which 256, yeah, divided by 100, which makes sense. So it does 256 squared plus j mu1 of Yeah, and then okay, so here we get that thing. It's we're taking the xt plus 1 in there because because we're taking the step, which makes sense. Yes, that's why we're applying that thing, which is this thing here, which is, I mean, I was gonna write it 6x. So if we look here, squared, which is taking the cost of taking a step, which is said in the thing like here. Wait, where did it say that again? I'm just making sure I'm like getting all the parts correctly. I don't know. These things are a little tricky, but I'm getting somewhere. I'm learning something. I'm doing something. Here, because I mean, it's the same equation there, right? This part here I graph. Was it k1 times x squared? My equation from u1 gives that, which inserts into there. Maybe it says something about it up here. In order to stabilize the system, we must have inserting the initial pulse in the dynamic, showing that this is fulfilled by mu0. So you substitute that. Substitute j mu 1 with k1 x squared, mu of x, this thing. So if we do that here and here, we get k1 x squared is equal to 2.56 x squared from that thing. This thing here, which is plus k1, and then in here we write 0.4 x squared, which, I mean, what the fuck is happening? There, 0.16. So, which is 2.56 x squared plus k1 times 0.16 squared. 1 minus 0.16 is 0.84. 0.84 k1 is equal to 2.56. This means that k1 is 2.56 divided by 0.84. 2.56 divided by 0.84. 3.476. 3.0476, which is the answer they get here in the nut. So cost function. So the cost function. So the cost function yay mu1 of x is equal to 3.0476 times x squared. I don't entirely understand why that substitution thing. I can probably ask ChatGPT about it. It probably says so in the lecture thing. Can you explain the substitution of j mu? Oops. J j mu 1 as kx squared. Is that a standard thing to do, or is it related to something specific within the setup of the question? Think about it. Semi purely quadratic cost in a linear policy systematic approach. You have a linear dynamics, purely quadratic stage cost. Well known from classical LQR theory that the infinite horizon cost to go under a stable linear policy. Quadratic. So it comes from the stage cost. Okay. Yeah. Cool. Nice. Awesome. This makes some sense. I'm gonna eat my food and then have a shower and then continue. But I want to make sure that I have eaten and have had my shower, before I continue, right? Otherwise, I'll be stressed about it. So I'm gonna quit here. Thank you guys for joining me for this little ride on this, little thing here. My goal is to continue for a while until I'm done. And if I'm done with that this week, then that's nice. Then I have a week and a half to just do the 4 exams and go back and understand things. And I do have other courses that I do need to do things into, at least in theory. I am, in a lot of ways, putting those off, but it is what it is, sort of. So, yeah, this was a good stream. I'm happy I turned it on. Thank you guys for joining me and my rambling, and I'll see you guys